I'll give you a quick second, Joe, to introduce yourself.
Yeah, sure. I'm a former graduate student as part of the cybersecurity research lab, and I'm a software development engineer at Ford at the moment.
Okay, great. So we want to start our talk today by basically giving some background as to where all of this is coming from. So right now I'm the director of the cybersecurity research lab at Carleton University. So cybersecurity stands for cybersecurity evaluation and assurance. And really what our goal in the lab is to conduct academic research in developing approaches, typically those that are systematic and that are rigorous, to enable us to evaluate and assure the cybersecurity of software-dependent systems. What exactly does that mean? What exactly that means is when someone comes to you and says, hey, I developed this really cool system and trust me, it's secure. The first thing that you ask back is you say, well, can you prove it? Can you show me that it's secure? How can you make that claim without the evidence to back it up? So what cybersecurity evaluation and assurance is all about is generating all of that evidence through analyses of software systems to support those claims about the security and or resilience of your systems. So what we do in the lab is we have a number of different research thrust areas, everything from doing various methodologies for conducting security analyses of systems, to threat modeling, which is about finding what are your valuable assets, what are the threats that would affect those assets, and how do we protect our assets against those threats. We look at formal methods for security. We look at metrics and measures. How can we measure the security of the system? How can we get indicators to know whether or not our system is more or less secure than a previous iteration of it, for instance? In developing security assurance cases, these are arguments that help us to support the claims about the security of the system that we have. We develop security design patterns, and of course, we work on developing tools. Now, in order to do all of this, we have a number of different foundational approaches that we take, most commonly based on formal methods, based on model-based engineering, data-driven approaches, algebraic approaches, logical specifications, and effectively finite state machines as well. And we apply all of this stuff in a variety of application areas. And most notably, we are interested in applying these into critical software dependent systems like critical infrastructures, industrial control systems, systems that use Internet of Things, cyber physical systems, as well as distributed systems. Now, to give you a bit of an understanding of the context for what we're going to talk to you about today, we want to talk a little bit about some of the questions that we ask in our lab. And one of the main goals we try for is to bake security into the systems that we build instead of bolting it on at the end. So this question is really about how do we move away from retrofitting security onto our systems, this idea of bolting it on after the fact, and how do we instead bake it in at all the different stages of development? So the general idea here is that we have this system development lifecycle, and there's a number of different activities that go along with that. And what we're really aiming to do is inject all of our security engineering activities into the various stages of the system development lifecycle. And only once we do this can we go ahead and then ensure that we're going to be on the right track towards developing a more secure and trustworthy system. So one of the things I'll note here is that you see security evaluation and security assurance as sort of pivotal as part of these different security activities. And that's really where most of the work that our lab puts out lives. So in addition to this, we also focus on developing system level approaches and tools. And the reason for this is we want to answer this question, right? How do we address the fact that security and resilience of systems are emergent properties? What this means is that even though we can prove or show the security of individual components of our system, we can't make any guarantees about the security or the resilience of the system once we combine all of those components together, because they start interacting in various ways and there is emergent behavior from those interactions. So we have to address these issues from a system level perspective. And what makes this challenging is that we have to also do this while considering the fact that often the needs and beliefs of the stakeholders that we have are subjective to their specific viewpoints. And because of that, they can contradict, compete, and conflict as well. So what we aim to do here to address these kinds of problems is we want to have more streamlined development processes with an explicit consideration of security risk at all of the different stages that we have, right? So very much following along the lines of what I presented on the previous slide. We want to work towards developing more system level approaches to address these security issues, specifically those that deal with connected devices and the interactions between various components, along with interactions with the people and with their environment that the system is operating in as well. We want to make sure that we can develop tools to help manage the size and complexity of the systems that we're dealing with. So often when we're talking about engineering these kinds of systems, we're not talking about little toy programs that we're developing in early year programming courses, but rather these are large, complex systems that are often at the center of many of our most critical systems that work for the functioning of our society, like a power grid, for example. So we really want to have tool support to assist and automate a lot of these kinds of analyses, because as we have larger, more complex systems, it's infeasible to do it any other way. And finally, we want to look at how we can start to generalize the kind of work that we do into more general methodologies, standards, guidelines, and policies that support the awareness and enforcement of the various security concerns that we have for our systems. So this gives us a little bit of an idea of the kinds of issues and challenges that we look to solve within the CyberC Lab. So our focus of our talk today is about developing secure systems, and more specifically, designing secure systems. And again, we have to consider that there are a number of common challenges that we face in this particular arena. First, we have these increasingly complex and heterogeneous systems, and that makes it very difficult to identify potential security vulnerabilities in such systems. We have to think about the developers of these kinds of systems, right? The software that goes into making these systems are built by development teams that are facing many different kinds of pressures. Often there's a business pressure to rush systems to the market for a competitive advantage, for example, which often goes against being able to adequately consider security and risk at all of the different stages of the development lifecycle. Sometimes there's just simply not enough time for the developers to be able to do that and do that well. And compounding these issues is the fact that most development teams that we have often don't have the know-how or the tools to help them support this development and the design of secure systems. And this often is from the fact that we have development teams that aren't trained in security or security engineering, and they're going ahead and they may be perfectly competent programmers, perfectly competent designers and system architects, but somewhere along the line, someone comes and says, well, we need to make this system secure. And they're left sitting there wondering, well, okay, I know maybe a little bit of something about how to do this, but I really don't have the guidance or the correct tools to be able to do this and do this well. So where we want to focus our attention here is at the early stages of development. Because this is where we're going to be able to really start baking in the security of the system, right? So in our talk today, we're going to focus mostly on the design phase. There's other work that we do, of course, that covers the requirements phase. But here, the main problem that we're trying to address is, imagine that you're a system architect or a system designer, and you have one of your managers come and tell you, well, that's great. We need to design this system. We need to make sure that it's going to be secure. Again, you may know how to implement certain controls, certain countermeasures to mitigate typical kinds of threats. But when you're designing these kinds of systems, you often have to make a number of critical decisions on how you're going to design the system, perhaps how you're going to structure all of the different components in the system. And each of those decisions are going to impact the overall security of the system. So you may have a number of different alternatives. Now, one of the problems you may face is you may make a decision to do something a particular way. You may get a new, what you perceive to be an improved design, but you don't really have an idea of whether you've made things better, whether you've made things worse, or whether things are exactly the way they were before, just in a different order, for example. So what we're going to do now is walk you through some of the tools that we've developed to help solve this kind of a problem. So I'm going to pass the talk over to Joe now, who's going to go through all of the details of some of the tools that he developed as a master's student working in the CyberC Research Lab. So Joe, go ahead.
Yeah, thank you, Professor. So I think I have control. Yeah, perfect. So as Professor Jason mentioned, so there was this need to create tools that actually are something that people can implement and integrate into their workflows. And that's where our work and our talk today focuses on. And so one such tool that we came out with was called Polaris. And I'm going to sort of walk you through the process of development of taking something from like basically nothing to an actual product that people can apply and then you and I can use. So we start off with requirements. So a lot of times we think about requirements as just, part of a documentation process, but the fact of the matter is that requirements is critical to actually setting the groundwork or the foundation for what we intend to achieve with our tools, right? So we can actually come back to it when there's doubt, when there's uncertainty in our development, or also when we want to see if we've actually achieved the goals that or objectives we set out to do. And so we set out a couple of key requirements that you see here. One is that this tool that we were coming out with had to be as accessible as it could be for as many users as possible, right? One of the major issues that we noticed with some of the work that we came across in this area was that they required tools that were so hard to find and also hard to use and get started because they had these weird dependencies and all kinds of odd requirements, which made it very cumbersome and would put people off from using and harnessing that kind of, those mechanisms or tools for their workflow. We also wanted it to be intuitive for people to actually design and analyze a system, right? We were talking about system level approaches. So in this particular work, we were focused on actually creating one of those constructs to help evaluate systems. And to do that, we need something that is actually easy for practitioners to actually understand and implement. So it lowers the learning curve and it helps them actually get to what they want to get out of that tool. We also wanted to present the analysis information in a manner that's actually visual and interpretable, right? And that means that we want things to actually be as much as we can communicate in a visual form so that it's easier. And again, it ties in with the requirements. The second requirement where it's intuitive and they can sort of get a easier understanding of what they're trying to see without too much of a hassle. And it also needs to be extensible for users. So, these are people who are developing systems, more than once, and they're not on their own when they develop systems. So we want to create a mechanism that can help them share these design details and artifacts to other designers, other engineers, et cetera, to work on or integrate into their workflows as well. So we took these requirements into as a core principles for designing this tool. And now, again, the key part was that as part of a requirement, we had to make something that was intuitive to design and analyze a system's structure, right? And so I start off by sort of sketching things out in a simple notepad and then prototyping designs that could work, or at least that I think could work, and start to discuss with our stakeholders. And in my case, it was Professor Jason and another professor who was involved in this work. And what that helps us do is basically get everyone on the same page, right? Because normally we all have discrepancies in how we think and how we perceive certain ideas. And so sort of putting things together in a rough form can help us iterate quicker and reduce the development time and other times going back and forth. right? And so this was a key part to see, okay, what could work, what couldn't, and what makes sense and what doesn't. So now that we had an idea of sort of a framework of what we want to implement, the next was sort of technologies, right? How do we actually go about implementing this? Most times, especially as students, what we tend to do is just jump out to the latest technology and start to work there because it's cool and it's nice to work in. Or we choose technologies that are very good at just one thing and then make our lives much harder. But in this approach, what we tried to do was sort of be time conscious and try to find an efficient approach where we could get the most things done with the least amount of effort put in. So during our search, we came up with two main core libraries that drove the implementation of this tool. One was Dash, which was by a company called Plotly, and what it helped us do is build real-time dashboards that were stateless, which means they didn't store information on the servers for each session, which is helpful because it minimizes the resources we need to have on hand. And it was based on Python, and it helped us integrate another library called Cytoscape, which actually helped with creating the drawing mechanics and the physics to create sort of the core parts of this tool. This was a little bit of a challenge because it comes with its own learning curve, and I was not familiar with Dash, and it has its own sort of way of doing things. But again, the decision was made to go this way because it had a lot of the core building blocks that we could then use to put together things very quickly. So combined with the design prototypes and these implementation technologies, you can basically start to iterate on sort of the minimum viable product of what is possible and get discussions going on how to iterate and what can be improved and what things will look like. The more concrete the product looks like, the more easier it is to actually gain an understanding of what it actually can do, what it could do, and what it shouldn't be doing. So all of these could be useful tips for your upcoming projects or assignments or even things you have in mind to get them from simple ideas to an actual real product. And speaking of which, I can actually show you a demo of what Polaris actually looks like once we built it out. So if I may exit this presentation, and I think now you should see the tool. Good. Okay, so this is Polaris, and this is something you can access on your site as well. And it's basically a web app that takes those core parts that we want to do. That's the design and analyze stages, and brings an intuitive, or at least what we think is an intuitive interface for system architects to design and then analyze your systems based on the methodology we developed. So in very simple terms, what you see here is a UML diagram, so Unified Modeling Language class diagram that you may have come across or will come across soon. It's a standard notation of representing systems or classes. And what we're able to do is basically enable system architects to design systems of design using UML, or even import JSON files with UML annotations and UML design. And this import feature can be expanded to include additional widely used formats for XML, like XMI. But at the moment, we take in a JSON file that helps us populate this information. We could also build this information here. And then each one of these nodes or these components can be annotated with additional information that is useful for the analysis we will perform at the next stage. So for example, in our work, without going into too much detail, key parameters that were important for these components were things like access rights associated with that particular component, and the privilege, right? And like who's able to use this at what level. And you may have come across these terminologies in your daily usage of computers. And those parameters, in addition to things like requirements, security requirements, so basically the constraints that this particular component, for example, the web server, needs to fulfill in its operation, and the design decision. So what kind of technologies are going to be used, and where applicable, we can add that kind of information, and that goes into the analysis stage, which I can show you here. So in this analysis stage, we basically have three main sections here. We have the system metrics, which are basically metrics to, well, analyze the system. And to put it in short, why do we need any of these, right? So when you want to manage something, we need things that we can measure, right? We need metrics. And you can apply that to basically anything, right? When you're looking at what's a good smartphone, you look at certain parameters, certain specs, right? Same with a vehicle or any other product or service. And similarly, when we want to manage the security of a system, we can find out what are the relevant metrics to measure and then see, okay, are we doing good? Are we making it worse? And set a baseline for what is ideal and adequate and where the system is adequately secure. And so here we've chosen this concept of attack surface, which is basically, the number of ways in which an attacker can get through to the system and compromise it. And we also have this UI where we could basically click on a particular component and we can see component-specific metrics over here. For example, we can see things like eigenvector centrality, which is a fancy calculation that looks at how important this component is relative to the other components based on where it's located. And so we can use this information and use these sliders over here to run analysis of, okay, if I have a very high level of access right, but a certain level of privilege level for this web server, how does it affect my attack surface, right? And we can see how these values are changing, for example, right here, based on the values we're choosing. And of course, based on which component you're targeting, those values change. And you can sort of run your analysis there. The methodology itself is explained in a paper and in a thesis, so I won't go into detail here, but you can see how this interface combines not just numbers, but sort of sliders and a visual aid to show what you're targeting, how things are coming together, and that just helps in making that analysis easier to understand. We also integrated another tool that we developed, Merak, which basically looks at the external data sources and analyzes what latest threats affect the component that you've selected at that given moment. And it sort of categorizes this in terms of what are unmitigated, what need to be mitigated, in which case we need to add more security controls, and what are extraneous, things that we don't have to necessarily pay attention to at this time because we don't see any threats affecting that particular component in that way. And so you can see all of this information coming together, and you can run these analysis and really get a better understanding of, okay, what changes and how our security improves or does not improve, and make decisions accordingly. And so what we were able to do in our research was to iterate on that design that I showed you, which, by the way, was about an online merchandise system. So think of a simplistic form of an Amazon with your web server, web client, and order processor, customer manager, and all that. And you can see different types of components here too, right? We can see things like a web server, but also data stores, right? Like a customer data store, which can have varying degrees of information in terms of what's important and what's not. So all of that is taken into account before iterating on the design and making it a more, or at least an adequately secure architecture. So this is an example of how that tool can help. And of course, you can generate summary when it works. There it works. And so that way you can then use this report for later comparisons and other types of analysis. So this is a tool that that we worked on that helps system architects analyze existing designs. So we're not making them learn new ways of doing things, but rather integrating their existing workflow into this analysis process to be more informed about the security landscape of their architecture. So if I go back to these slides here, there we go. So that was Compass, and there were a lot of quirks to it, which I won't go into full detail right now. But I also briefly talked about another tool that we also worked on called Merak, which pulls in from external data sources. And that's already two tools for people to know about or think about when they're designing or at least looking to design secure systems. And so as we were discussing this problem, we noticed that there is a lot of potential for additional tools to be developed in this area. And it will be really hard and cumbersome to keep up to date with what's going on with each of these tools, what is new, what is not, and all of that information. So we were really brainstorming this idea of bringing all of this into a toolkit. All right, so that way, so similar to how Microsoft Office is a single place you can go for different types of tools, and this could, be a tool that could bring together tools associated with secure system design. So as with the previous tool, Polaris, we worked on the requirements that would dictate the design of this toolkit. And there are quite a few in this case, right? So one is we want to support a scalable deployment of heterogeneous cloud-native web applications. So it sounds pretty wordy, but essentially we want to be able to deploy different types of applications in a way that reaches as many people as possible for as long as possible, right? And so if there are a lot of people trying to access that particular tool, or they should be able to do that without any issues. And we also want to provide a straightforward method for developers to integrate their tools into this toolkit, right? That's part of the appeal, is we don't want to add an additional workload to developers, but rather make it fairly intuitive to integrate their existing tools or new tools into the toolkit for others to use. We also want to automate the management of these applications, right? These tools in terms of availability and in just general maintenance, right? Making sure they're securely being operated and they have a great uptime. And similarly, we want to automatically manage the deployment of tools, right? And when we say deployment, it's not just the initial deployment of taking the code and getting it online, but rather ensuring we can integrate up-to-date, updates that are being integrated from time to time or on the daily, and making sure all of the deployment is automated as much as it can be to minimize the resources that need to be put into maintaining this toolkit and the tools themselves. And we also want to enable the deployment of applications with independent code repositories and development pipelines, right? So this means that if you're developing a tool, you get to own that code repository and the process associated with that. So things like issue management and CI/CD, continuous integration, development pipelines, and other factors, wikis, and so on. It all comes down to your control, which again adds more flexibility for more types of developers to add their tools to Compass. And finally, we want to provide a web application to showcase these tools, right? So that helps with the exposure of these tools, helps people find tools that they haven't heard of or seen of or knew existed, or they could go back to tools that exist and see if they can contribute or gain feedback on, and so on. So quite a large list to satisfy for this toolkit. And so we came up with this architecture to help satisfy these requirements. And I'll talk about the technologies that make this happen in a little bit. But at the very high level, we have users that are being routed to different services that they request, and these services or tools are being served as basically Docker containers, which to their end is just a web application, but behind the scenes, these things can be spun up and spun down, and makes it very, very easy to satisfy the requirement of ensuring we can support heterogeneous tools and ensuring scalable deployment. So we'll go in detail for each of these mechanisms that are core to making this toolkit functional. Starting with Docker. Now, Docker is a very popular containerization mechanism, but not a lot of people actually understand what goes on here. But essentially, what Docker tries to do is it tries to take out the complications of a virtual machine with all having a guest operating system and all of the kernels and things that are required, which makes it very loaded and very hard to deploy, and sort of breaks it down to just the application part of what we need to deploy. And it shares the kernel of the guest operating system or the host operating system. And so a lot of that means basically we can deploy applications very quickly and take them down as quickly. We can isolate them in terms of the resources. So these containers can operate as if there's nothing else connected to them. So they have their own networking, their own CPU, their own memory, and they know nothing beyond themselves, which makes it great to move them around and make sure that we can isolate applications. And so should something get compromised or should something fail, we can spin up new containers, or we can at the same time round down things to minimize resource consumptions. So it makes it a very flexible structure to package code in. And the beauty of it is it supports all kinds of technologies, or almost all kinds of technologies within its construct. So it helps satisfy the requirement for having heterogeneous applications being deployed. So as long as it's a web app, we are able to take that Docker container and use just the interfaces to route target audiences to that application. So how does this actually work? Within the application itself, all you need to add is basically a Docker file. And this is a file that is just a set of rules to tell the Docker engine what application it is, what kind of images it needs to pull. So when I say images, it means, like a specific type of operating system or specific set of libraries like Python. And you can pull it all from this pre-built registry of different images, so you don't even have to build them yourself. And then you can just say, how it can instantiate your application in that context. So building the required dependencies and so on. And then you can expose the needed ports for the interface to communicate with the outside world. And that's basically it. And you can integrate this part as part of your continuous deployment process, which we'll talk about in the next slide. And we can take that Docker file and your application and generate that into a container image. And this image is what is used to generate or spin up new containers or basically anything related to your application. So as long as we have a record of the image, we can spin up as many containers of that image as we want and do anything we want with it. So we combine this flexibility with Git, as you might have come across, which is a simple version control. Well, not simple. It's a very sophisticated version control system, and as part of that, we also are able to use things like continuous deployment, continuous integration, which you might have come across as terminologies in the industry, but essentially help us automate things like testing our code as it's being built, and if it succeeds, building it into the needed artifacts that are needed to deploy it to production, to end users. So we currently use, for at least Polaris and Merak, we use the GitLab's own CI/CD pipeline, but if you're developing an application for Compass, you are free to use whatever tool that works for you. And this way we can ensure that no matter how many code changes are happening and by how many other people, they are consistently checked for quality and they're checked for integrity. And the ones that satisfy a quality criteria are deployed as these container images that we talked about. Now, as I mentioned a little briefly earlier, these container images need to be stored somewhere so that we can go and pull it up and run it either on our computers or on a server and so on. So that's where this concept of container registries comes in. And these are just basically simple hubs where you can store container images. So container registry is a little deceptive name, but essentially it stores container images. And that way, anytime you go there, you can pull the latest image or different types of images that you put up. So GitLab provides that for us as well. So where each of these tools have their own container registry, but you can also put it in other container registries like Docker Hub and all kinds of other ways for us to pull that information. And then we use traffic proxy, which is a reverse proxy of sorts. And all it really does is basically route web traffic to the requested tools. But the way it does that and the way we've configured to do it, or what it allows us to do, is very sophisticated. And that's what is really helpful, in that it helps us ensure that the connections are secure, integrate things like firewall, and do load balancing with containers. It helps us monitor these container health, which means that if a container fails or something is compromised, it can monitor that for that and spin up new containers to replace that. So it minimizes the downtime for end users. So it can do a lot of these sophisticated things and with minimal effort relative to other architectures. In addition to traffic, we have our own custom scripts to sync up with these different container registries that we talked about and deploy the latest versions of the available tools. So for example, if I want to make a change to the website or make a change to the tool, I don't need to go the whole route and talk to the server and see if I can push the change. I just need to push it to the code repository and attempt a merge of the branch, and it'll run the automation tests, see if it works and everything is good as expected. And if it passes, it's able to make the container image for me and deploy it into the container registry. And our scripts are able to notice that there's a change, pull that and deploy it at the best possible time to make sure that it minimizes the downtime and the latest available version is served. So a lot of this automation goes on so that the developers and end users have an optimal experience based on their context, right? So developers don't have to spend a lot of time in terms of troubleshooting the entire pipeline, and end users don't notice a lot of downtime, and they have just smooth ways to move around between applications and do what they need to do. And all of these are critical considerations because we're dealing with production applications, right? So if we want actual practitioners to use our tools, we need to create tools that are worth using. And these kind of criteria are key to that. So Compass is also available as a website. So remember our requirement, I think it was 6, where we wanted to showcase the actual tools of what is available. So that is what we have here. That you can access as well, and it's a fairly simple site that gets to what is going on, and behind the scenes is all that fun infrastructure stuff. But on the front, it's fairly straightforward, and you go explore. And we talked about the 2 tools that are available right now, so you can learn more and see the licensing and what type of project it is, what the tool is about. You can learn how to contribute. So if you're looking to build a tool for Compass and you want to learn, okay, how do I contribute, or either build a tool or contribute to existing tools, you can connect to that. And also we have the link to the GitHub that holds the tools that we are currently hosting in our infrastructure. So Polaris, for example, and you can see it's open source, so you can go through the code. You can see, for example, what the Docker file looks like, and you can see it's basically a set of rules, right? And it's fairly straightforward. So it's not a lot of configuration time relative to what the benefits give us. So getting back to the presentation, yeah, right here. So let's talk about developing tools for Compass, because there are great opportunities for people who are doing your 4th-year projects or doing things as part of your assignment.
Sorry, Joe, we only see the GitLab still. Oh, sorry. I'm not sure why it didn't show up. Okay. Can you see it now? Can you see the...
Nope. Yeah, I can see the GitLab.
Oh, just the GitLab? Okay, apologies. Yeah. Oh, right, I keep sharing the application. Okay, how about now?
Yeah, not full screen, but...
All right, let me try that. And now?
Yes.
Okay, cool. So this is a slide I was showing, you didn't miss much. But the part I want to talk about briefly is developing tools for Compass. So a lot of you may be coming across your 4th-year projects soon, or assignments, and where you may be required to create some sort of project. And this is a great opportunity to contribute to Compass. So why would you want to do that? We'll talk about the benefits first. As a student, I think it's great because you get an exposure to developing truly production applications. And so it gives you sort of a feel of the kind of quality and the standards required to get an application from nothing to an application that goes to end users and practitioners. It adds real use case and exposure to your application. And I think, it gives you exposure to how things work during that process, right? Getting it from a project style work to production, what goes in between, and getting those parts together. So it's a fun challenge to tackle. And we also have, no specific technology stipulations. So you are fairly free to use technologies that work for you and that you think are ideal to create whatever application, as long as it's a web-based application, as you can see in the requirements. And so each tool, as we mentioned, can have independent code repositories, development pipelines. So you're in control of that, and the contribution policy. So they don't all have to be open source. They can be some combination of closed, open, or anything else. So there are three main requirements that need to be followed if the tool needs to be considered for being added to Compass. One is that it needs to solve a security-related problem. Now, remember, Compass Toolkit is for tools relating to secure system design. But they're fairly broad as well. So there are a lot of opportunities for different types of tools and different challenges to be taken up there. They need to be web-based, and this is to fulfill the criteria that these applications need to be as widely accessible as possible. So you don't need to satisfy particular dependencies, make sure it works on someone else's computer, and all of that hassle. Especially thinking long term, this is a better way to do it, or at least I would advocate for it. And being web-based, you can have different types of applications. So they don't always have to come with a user interface. They could also be in the form of an API or sometimes both. So Merak, for example, has both an API to it and a user interface to work with. And it needs to be developed in a cloud-native way, which is another way of saying it needs to be containerized so that we can standardize the process of deployment, ensure that it's healthy and it's having as much uptime as we can give it. And right now we support Docker, but maybe in the future, the other technologies could be supported as well. So with that said, I'll hand it over to Professor Jason to summarize the talk.
Yeah, so I just want to put a bow on this, I think. So thanks, Joe, for all of the details about Polaris and about Compass. So really, what are we talking about today, right? So our main goal within the CyberC Research Lab is advocating for this idea that security needs to be built in instead of bolted on when we're designing and building software systems. And in order to do that, we need to have better tools that can help support designers in this effort. And in particular, we need to help them deal with the complexity of the systems that they're building. And we need to support them with automated security analyses. And that's what's going to help us to guide them towards actually engineering more secure and more trustworthy systems. And Joe talked about a couple of tools that were developed as part of his own master's research, Polaris and Merak. And those tools then led to the development of Compass. And what Compass is just this web-based toolkit. It's really just a back-end infrastructure to help manage the deployment of these secure design tools. And it's meant to serve as this one-stop shop that you can basically push your tools to Compass, and Compass will effectively host them and enable end users right here and now to go and start playing around with your tool, right? So that's really what the main idea of this talk was about. So the last thing I want to mention is if you're, Joe, I don't have control. Can you go to the next slide, please?
Yes.
If you're interested in contributing a tool to be used with Compass, there's lots of different ways in which you can do this, right? There's opportunities as fourth-year capstone projects. So if you're a Carleton student and you are going to be doing a capstone project in the coming years, it's very, very likely that I'm going to have projects available that are going to be aimed at developing tools for the sole purpose of hosting them within Compass afterwards. So that could be a really nice way of developing some portfolio material when you're on the job search after the fact. If you've already been part of your fourth-year projects right now and you're interested in undergraduate or graduate research, there's also opportunities available there to come join us in the lab and to work on these kinds of projects. So there's a number of different resources that you can check out if you're interested in contributing. So there's the Compass Git repository, the URL's on the slide here. It's also available from the main Compass page, which is just compass.carleton.ca. There's the contributions page that Joe had showed as part of his demo. And anything about prospective students, whether you're interested in a capstone project, undergrad or grad research within the lab, you can check out my webpage, which is going to have information on how to get in touch with us to talk about these sorts of things. So really, this gives a good idea that if you're interested in these kinds of tools and you're interested in developing and solving these challenges to help designers and help architects build more secure software tools, or more secure software in general, I suppose, then get in touch with us, because I think there's lots to be done in this space. And what we're really aiming to do is grow this toolkit, right? I see Compass myself as the secure designer's toolbox, right? Just like a home maintenance person would come to your house with a toolbox and it'll have hammers and screwdrivers and whatever else, tape measures. We're looking at Compass in the same way, as it's going to have tools to help you do all kinds of different security analyses to help build better, more secure, more trustworthy software. So if you're interested in that, please feel free to reach out to us. Beyond that, Joe, if you can go to the next slide, please. We do have a number of related publications as well. So Joe's master's thesis details all of this stuff. It's a long read, but if you're interested, you can go and have a look. And then we have two additional papers, one that talks really about the background of what the Merak tool actually does, and one that talks about what the Polaris tool actually does from a more technical background. So how it actually works and what the analysis actually is all about. So if you're interested in learning a bit more about that, by all means, you can check out these references. And with that, I think we're going to end here. So thanks a lot for your attention, and we're happy to answer any questions that there might be.
Yeah, thank you so much, Dr. Jaskolka and Joe Samuel. Like, this is a great initiative. I personally love seeing the accessibility it gives towards building like secure systems. That's amazing. So yeah, we'll start with questions. I think like Vern had his hand up. Vern, do you want to go first?
Sorry, I was just clapping. That was
You're
just...
clapping. Okay, my bad. Cool. Does anyone have questions?
Yep, I've got a couple questions. So I guess just to start there, one of the things I noticed when you were demoing Polaris was that there were concrete numbers for mitigated and unmitigated threats, I'm assuming within the system design. Is there a way for the designer to know if that threat has been modeled out or accounted for? Or is it more of a, hey, make sure that this is accounted for and you have to do it manually?
Yeah, that's a great question. Sorry, I jumped in.
Yeah, go ahead.
Okay. Yes, so we have Merak, as I mentioned, is a separate tool that provides a little more elaboration on what those like threats are and stuff. And we are hoping to integrate a feature there to like sort of have a checklist of sorts to help say, okay, we've changed it. But right now we can accomplish what you've said by actually taking the threats that you were alerted to, and we also provide the mitigation information, like what you have to do if we have that information available to mitigate that and what raised that threat in the first place. And if we see that in your requirements as part of something you're going to implement, that should, in theory, bring that mitigated threats or unmitigated threats down and go to the mitigated. I say in theory because that mechanism it's not direct. It's more of, it's still going to run the same analysis, but now it should not be picking up those as unmitigated.
Yeah, the general idea with how those numbers are generated is in the Polaris tool, you saw that there were two fields that you can fill out that are related to your security requirements, which are effectively describing protection goals for the particular asset you're dealing with, as well as specific design decisions, which is basically, have you made decisions about the kinds of technologies that may be used to implement those components? And what the Merak tool is doing is it's actually using that information to query a number of vulnerability databases to identify if there are known vulnerabilities with respect to the design decisions that you've made, and then cross-referencing the results with that to see if you already have requirements that would prescribe protections relative to the threats or vulnerabilities that it found. So effectively, when it says you have unmitigated threats, it means that we found that there are existing vulnerabilities with respect to your technologies for which you don't currently have any requirements prescribing any sort of control or countermeasure for. And then there was a last part of that that has extraneous requirements. And that's when you have requirements for which there are no threats that have been identified, which effectively tells you maybe you don't need that requirement. It may be extraneous and you could perhaps remove it, but that's something that a designer would have to use their discretion on because maybe they simply don't have all of the design decisions selected yet.
Okay, thank you very much. I do have another one here as well, based on what you guys sort of said with the mitigated and unmitigated, is I used something called White Source during one of my co-op terms, and it was a program that effectively like looked for vulnerabilities in code and not really at a design level, but more so went through a network and did different stuff. Does Compass, or is Compass goal to eventually, if not currently, include those sort of statistics as well?
So in future, there would probably be other tools that will be developed to do similar kinds of things. A lot of the focus of our main research areas are at the early requirements and design levels. So we don't do a lot of source code analysis from a research side of things. I do have many fourth-year projects, though, that end up going towards this direction. There's actually one ongoing right now that's doing effectively source code analysis in a very similar way to the way Merak works, querying the databases in much the way you're describing. Unfortunately, Compass wasn't available or ready by the time fourth-year projects started this year, so they're not going to be housed there directly. But it's something that we're going to consider moving forward from here. Does that answer your question?
Yep, that does. Thank you.
Awesome.
I guess just one of the other questions I had here was, would one of the goals of Compass be to offer well-formulated design implementations? Like if someone was to, or I guess even Polaris, was someone to input like, hey, I want to connect to the server this way using like this methodology, could Compass say, hey, actually that's bad, you shouldn't do that?
So it won't tell you first off, hey, that's bad. What it will tell you is if that was your design and you had an alternative, it would be able to give you indications of whether one is better than the other. But it won't be able to tell you that one single design is good or bad because the metrics aren't interpreted in that way. So they're not on an absolute scale like that. Joe, you want to add something?
Yeah, well, Ryan mentioned Compass. So that could be a tool you could develop, Ryan. So yeah, so it's not limited.
Yeah.
Sorry, I guess I got away from myself there on the definition, but I more so meant if it would suggest, like when someone makes a design choice, if it could say, or like look at that and be like, well, there's these other formal processes which can be followed to do a similar task.
So it's currently there's no tools that we have that are that kind of recommendation, which I think is what you're getting at. Correct me if I'm wrong, but sort of saying that you've done this, here's perhaps some recommendations on doing it in a different or better way. Is that where you're getting at?
Yes, more so like just taking pre-established methods and being like, here's the options for what we think that you're trying to do.
Yeah, so we don't currently have tools that do that. There's a couple of reasons for that right now. Partly, it always becomes a question of whether design becomes a science, that every previously thought out design is good, and therefore we should just keep doing things that way. Design is sometimes considered an art, which means that every single system that you're designing has to be given its own individual treatments. But what I do have ideas for, we don't have tools just yet, but applying design patterns. So there's security design patterns that can be used. And one of the ideas would be, can you identify, for example, the applicability of a design pattern given some design that you submitted to the system? And it can start suggesting, hey, maybe you should apply this pattern. These are the benefits and these are the drawbacks if you were to do this, because you can have these kinds of pattern repositories. But again, we don't currently have that. So,
and if I may chime in as well, like, so during our research, we actually came across a work that did do this as a tool. And guess what? Like any other, most research works, that was impossible to find, yeah, it just disappeared into the void. So that's one of those challenges we're trying to mitigate here as well. So I guess you can tie that with a research opportunity and come up with a tool on that front, or even as an extension to Polaris or something like that. Yeah.
Oh, thank you very much. It looks very interesting, and I'm excited to take a look at it.
Great.
Thanks.
Dima, do you want to go?
Yeah.
Yeah. Thank you, guys. It was a great presentation. There's a couple of notes I have regarding the Polaris. Is there any kind of documentations or tutorials or some kind of guidance how to work with the system and how to interpret the results?
So yes. So okay, there's two sides to it. So there is the development side of things and interpreting the results. So the interpreting the results stuff goes onto the methodology side. And yes, we do have research papers and the thesis that walks you through what does it actually do, what do things mean, and also how to interpret the results and so on. So and there's a fairly simple way. Maybe if I get a chance, I can try and port that information into a wiki for Polaris. In terms of developing, there is annotated code, and there is a wiki that is in progress and probably will be for a while. And so I'm working to add things on it. But of course, if you're interested in contributing, that's a great incentive for me to accelerate that effort too. So feel free to get in touch if you have that incentive. You can take a look at the code. It's already like open source, so you can check it out. And if you're like, oh, I like this, or it doesn't work, but I'd like to contribute, I can fill you in with the details and add it to the wiki as well.
Was your question more of, is there a tutorial on how to use Polaris in the first place?
Oh, is it that?
Yeah, because
yes,
like the tool looks kind of interesting, and like I'm trying to look into application and my work and what I'm doing right now. The application is interesting because I'm right now working on the project design, and the tool looks applicable and actually have a response somewhere in my heart. And I'm just trying to understand how I can use it, and that's why I'm asking like about the documentation, whether like how to apply it and how to analyze, and especially I interpret the results, because I would need to explain them to the rest of the senior management. Yeah. So the Joe, correct me if I'm wrong, but I don't think there's like a step-by-step tutorial on using the tool right now.
Yeah, and I can work that through the wiki. Like right now, there's an overview thing where we walk you through like what the different pages do, but we don't go into detail of like how to interpret the results, and that's a key part of that tool. But that's a good point you brought up, so I could take a look at that one. Yeah.
But the general idea is that there's a few tabs. The first is to design the system. That's effectively draw out a class diagram of the structure of the system. From there, all of the analysis gets done in the background, so you don't actually have to do anything special. And you'll start getting the results. And then in terms of interpreting the results, the best documented form of that we have, I think, at the present time, is a worked out example with a couple of different design alternatives as part of Joe's thesis. That basically shows, okay, this is a scenario, this is the initial design, this is how we make a decision based on the information that Polaris gives us to then make some changes. We run it again, we see what we get, and it kind of walks through that sort of scenario. That's the best way to currently look at how the the results can be interpreted. But the design side is just draw it using the tool. And if you come across any issues, there is a feedback part as well that will create.
It's only me right now, so
that will create issues for Joe to fix.
Yeah, I quickly tried out, and it seems that there are minor stuff happening with the Firefox, but that's completely normal.
And that's the advantage of having it as open source, right? So like it's something that people can contribute to. It's not just one person behind the whole thing. So that makes it even more of a reliable recommendation for your organization or other opportunities, and you can sort of port that to your own environment, etc.
Yeah.
But
that's certainly that's why I'm saying, like, it looks really great, and I'm kind of looking forward to get into the systems and look into the examples, especially like regarding
I'll
the
try to
of it.
port that to the wiki too. Yeah,
that would be nice to have. And I guess there is one of kind of a silly questions I have regarding the system of Docker containers that you have. It seems you're using the traffic proxy. Like most of the time, when like I'm facing work with the Docker containers, and especially like load balancing system, usually people suggest using the Nginx as a reverse proxy. Is there like any
very good question
kind of like positive effects of the traffic proxy compared to the Nginx?
Yeah, that's a very good question. Yes, so Nginx was what I used to do as well for reverse proxy. It's fairly straightforward, but the problem is there are a lot of logistics to maintaining a web application, right? So the most obvious one is like, certificates, right? Like provisioning your SSL certificates. And as you may know, these certificates are not like one time only, right? They expire and you got to be renewed. Sometimes they have to, some issue happens with the entire way it's provisioned, so they just need to be renewed, like it happened recently with Let's Encrypt. And so that's just one example. Then there's firewalls and other protocols that need to be followed. Nginx or Nginx advantage is that it's very lightweight, but it's also lightweight because it relies on you to configure things, right? Traffic is fairly lightweight. I wouldn't say it's very lightweight, but it's fairly lightweight compared to like most other kind of packages. But what it brings together is its ability to basically create middleware between that reverse proxy and your actual containerization mechanisms. And so that is a big save. That's where, a lot of our provision, so all our SSL provisioning is automated. Our security checks, health monitoring, all of this is actually comparatively as a package much more lightweight than having those integrated to Nginx. Nginx is more tried and tested, which is still a more reliable way to go long term. But I think this is used by a lot of orgs for quite a while, and adds that. And in addition to that, it has a lot of advantages in the way it works with Docker as a technology. So service discovery and things like that. So adding new services, provisioning URLs, and all of those things so those are like those little things, right? But they don't seem to matter until you actually do. And then it's a big headache to get things done, right? So that's where it is. I'm, again, fairly new to, it was a learning curve for me too, but that was the reason I went that way versus Nginx. Yeah.
Does something manage orchestration for you in the sense, like
yes,
spinning up more Docker containers? Like, is that
yes.
Trafic or is it something else?
No, so that's actually, Trafic contributes in terms of load balancing, but basically Docker Compose, you might have heard, is helps with the primitive orchestration, but the architecture is built in such a way that we can actually migrate to the pod system of Kubernetes. So we don't have the need, because Kubernetes is very useful when you have like multiple hosts, like actual multiple servers, clusters, and things like that. Then it's a very useful tool. But right now we don't have that infrastructure within Carleton just yet to support that. And we don't need it yet too. So Compose would do, because it brings a lot of simplicity to the way we can manage things. But we can, thanks to the combination of Docker and Trafic, we can put some very, very clever modernization and health monitoring and things. So we get a lot of the benefits of Kubernetes without the weight of Kubernetes. So yeah.
Okay, so like, do you guys at this point support like multiple containers for a toolkit, or you do?
Yes, and to a certain extent is actually automated too. So it can spin up based on how much is needed. Our resource within Carleton is a little limited. So if the traffic just blows up, obviously we're going to have issues, but it's still clever issues. But yeah, so it can automate the scaling and provisioning of containers and then take them down to minimize resource usage. And then some of these apps like Polaris are actually stateless, which means we don't even store the actual state of things going on, which is great, like more secure, but also you can have poor internet and stuff, and you don't need to worry about like your connection hanging up and losing your data and things like that. And we don't need to worry about storing that kind of data and have all that resource and stuff. So yeah.
Yeah, and it's also like kind of like a security thing, right? Like storing like the
exactly
critical design systems of security itself stored in.
There you go.
Yeah, for sure. Yeah, that was actually something I was wondering as well. Cool. Yeah.
So there is a compromise, of course. At the end of the day, it's still a little, depending on how you look at it, it's still a little more risky to deploy it on the web to a large scope of issues versus a simple application, not simple, but an application on the desktop. But of course, they both have their disadvantages as well, right? And and it's more of just a balancing act. And for us, having it more accessible was far more valuable compared to having it work on a computer, but it's more secure, right?
But don't you think that, you know, having a stateful system as well is valuable if you do want to kind of like start moving towards this, you know, people using this in scale? Because I feel like it is a kind of a barrier to like user experience to kind of have it in the stateless. It could be, I guess.
It is. To be fair, stateless is a little misleading. Stateless is a marketing kind of gimmick, but it's we always have state of some sort, right? It's where you hold them is the key. And when I say stateless, we're basically very clever about the way we hold state, in that we don't hold it on our servers, we hold it within your browser mechanisms in ways that could make sure it's still fairly protected, but also we don't need to carry all that load. Now, Merak, the other tool, is not stateless. That does have state, and it actually has two different types of states that it handles, like, you know, the threat data and all of that. So there's always like, it's a design consideration, right? So when you're thinking about the application you're trying to build, we were looking for efficiency and like optimizing that part. Like, we don't want to use a lot of resources because we're going to have a hard time getting that. And so where we could, having opportunities to minimize the need for something is a consideration that we had for Polaris going stateless. Yeah.
Interesting. Cool.
This is my kind of crowd. That's good. Yeah.
Well, since we're talking about like, you know, like wikis and documentation, maybe you guys can even provide like, you know, like a native solution for like documentation. I don't know, something I was just thinking. Like, as part
you guys had a pretty good one. I briefly took a look at it at the CSOC one, I think.
We're using something called Gitbook. It is free for open source projects. Nice. It works like you can synchronize it with a GitHub repository. That's what we're doing. But I don't know if it would meet all your requirements in a sense to be as flexible. It makes sense for like a small organization. I'm not sure. You can look into it. It's still a good.
I will.
Platform.
Yeah.
But even if I'm saying GitLab has its own like kind of wiki built-in system.
Yeah. That's what we currently use within, but you can tie it in with like Confluence and stuff, but we're not like that big yet. So, but I guess when more tools come in, things like Confluence would make more sense. And if we have a good number of open source, we could actually reach out to them and say, hey, we're nice people, help us out.
Yeah, Confluence has its own drawbacks, I would say. After a couple of years experience working with that, it doesn't actually fully support the complete Markdown. So
they all have their own. Yeah.
So I would actually considering right now to transfer all of the documentation that we have within an organization to something like Wiki.
Right. Yeah.
Like just a basic Markdown that actually have way more powerful than Confluence.
True.
Especially writing something like tutorials or like guidance for step-by-step stuff.
There's also read the docs .io, I think, for open source. I haven't used it. I've come across it across a number of areas, but you need it to be open source. And when we needed it, it wasn't open source. The tool wasn't open source, so we can request for it, et cetera. Logistics problem, but yeah.
That's fair. I was going to ask, I kind of forgot. Yeah, so like, I feel like, you know, the infrastructure that you guys are building here is really interesting. And I feel like it can be applicable to like more projects in a sense, but that might not be security focused or, you know, design specific or in any kind of way. So I'm curious, like, is there some kind of way that you can, like, maybe you're trying to, you might plan to expand in the future, or like kind of make this whole system modularized, that way other, I guess, initiatives can also use it. Because I guess, like, the reason I'm asking this question is one thing that we're trying to do at CSOC is kind of like encourage more people to work on projects. And what I want to do is also like give the students a kind of a platform to kind of host their stuff on. So maybe like a common project hosting service in a sense for the students. And I feel like something like the infrastructure that you guys are building would make sense a lot for the community in that kind of a sense. I'm curious.
Professor
Actually,
Jason might have a.
Yeah,
I might suggest here something. There is a tool called Travis CI that you actually can use the CI/CD implementation, and it actually self-hosted system that you can actually get the real running up there.
Yeah,
Okay.
From our perspective, Compass is designed really for the purpose of these secure design tools. That being said, if you removed that requirement, and then Joe, correct me if I'm wrong on this, but the infrastructure doesn't change. That requirement is just sort of an internal one that enables us to have a coherent set or collection of these tools, right?
Mm-hmm.
Theoretically, it could host whatever you want. But again, for the purposes we're using it for, and we've built it for, that becomes one of the requirements. I suppose there's a way to basically port the infrastructure that we've developed for just a general purpose. I don't know if there's a way to sort of, I guess, isolate or have effectively separate drawers in the toolbox, if you will.
Well, I think
Gotcha.
part of the toolbox advantage is that it needs to be focused, right?
Mm-hmm.
A good toolbox is efficient because it's focused. It's you have someone coming to fix your AC, they have the tools needed to do that job rather than everything else, right? So it's part of an advantage, in my opinion, I think, having the focus. But that said, of course, there are always going to be other needs, and the advantage that we have is that we can now either port or mimic similar architectures for such platforms, other requirements, without having to lose the meaning of Compass, right? Because that way we attract a niche and we actually are able to preserve that, rather than people saying, oh, now it's just all kinds of stuff, it's hard to find what I need, right?
Mm-hmm.
Or at least that's my just intuitive feeling right now about it.
No, I agree with that for sure. Like, is that like your code for the infrastructure side of things? Is that open source as well?
No.
Okay.
Probably won't be, to be honest.
Okay.
Yeah.
That makes sense. That makes sense.
Security reasons and stuff. Yeah.
That's right. Just curious. Cool.
Yeah, because just to add to this is there's part of this that is running on the Carleton research infrastructure, which means we have some responsibilities to maintain that, which is why we have the Compass code closed, but the tool code is open because you can contribute to the tools quite easily.
Cool.
Yeah,
definitely, for sure. Makes sense.
Yeah.
Cool. By the way, I created a quick page for this event on the thing. So if you guys want to add to this page, feel free to go ahead and add any more resources. I'll add a couple more things if I can think of something, but if you want to kind of improve this such that it's more understandable for people, that might be looking at this for the first time, rather than having to go through an hour-long video.
Sure.
Might be a good start. No.
Yeah.
Yes, it's because I'm also here, so they won't like to see my face there as much. So no. But yeah. Cool. Thank you so much, Professor and Joe. Like, honestly, it's been such a great presentation and such a great initiative. So like, it's really cool to see, like, Carleton and us at Carleton, like, working on cool stuff that actually might make a difference in the world. So yeah.
So look forward to seeing some tools there.
Yeah. So that's the same thing I was going to say. Is if you're interested, anybody who's on the call, anybody who's watching back the video, feel free to reach out and get in touch with us. If you have your own ideas, we have ideas, let's chat.
For sure. The other thing that I'm also trying to do this semester is kind of surface some projects like this that are being worked on in the Carleton community. There's also a few some societies are working on things like that. Just want to find projects like this and kind of curate them so that maybe there's one-stop shop for just people to find what kind of things to work on. So I will, if you're okay with it, I'll definitely add Compass on there as well, and kind of as a potential something for students to work on. And because the hardest thing is, I feel like as students, it's finding meaningful things to work on, right? Like everyone wants to work on projects, but they don't know where to start. So kind of surfacing what's being worked on and people that you can reach out to would be valuable, I feel. So I'll try to do that. Yeah.
Excellent. Yeah, sounds good.